Hello, everyone. I'm going to present some work that I've done with a couple of my collaborators. Basically, we've made this tool, which is a visualizer for various different types of SSA programs, not necessarily specific to LLVM and MLIR, but they are good examples of the sort of things we're trying to visualize. So what are we trying to do? Basically, we want to take our intermediate representation of our program, and we want to have different ways that we can view the data, view what's happening in the program, and display this as a graph to the user and let them basically see what's happening in their program and try to help aid them in working out what's going on. So the two main things, at least we've looked at the moment, are modeling the path that data flow takes through the program. So if you look at the graph on the left, hopefully, I'm not sure how well the colors are showing up, but the black lines here represent data flow. So you can sort of see that the output of the first add function goes into the input of the second add function. On the right, there's more of an example of what's going on with the control flow. So in addition to having all the data flow of your program, we're also sort of representing the control flow graph as within the same diagram. So the green wires are meant to represent control flow. Right, so there's certain features of IRs that make them difficult to draw, basically. So one of the things that is, crops up in both LLVM and MLIR is that they have blocks and regions which put a lot of constraints on the graph you're trying to draw. So you want to group up certain operations, and you want to have, for example, in MLIR, so I think the one on the left is LLVM. We want to, or it's some approximate, I can't remember which one it is, but in any case, we have these basic blocks, and data flow is allowed to travel out of one basic block and travel into another basic block. And so we end up with quite a big mess of having sort of our blocks, which are considered as big nodes of our graph, but there are things inside the blocks and wires coming in and out and all over the place. The tool will deal with all that for you without any sort of without you needing to do anything. The other sort of feature that we want to natively be able to support is that your SSA values can be used lots of times or used no times at all. And we didn't want so if you're trying to visualize your program, you shouldn't have to say, oh, I need to put in an explicit node here to copy my value. It just all happens automatically. And so these two things are what separates this from trying to use a more general graph visualization program like GraphViz or something to deal with these sort of visualization problems. So what actually happens when you try to visualize things? So this is the sort of approach we've taken. So you start with your IR. So yeah, we have translations for LLVM and MLIR. We also have this translation for our sort of toy language, SD-lang, which shows off some of the features of our tool. All these things get mapped to this hierarchical graph structure, which is the sort of founding block of, basically it describes everything about what is going to happen in the visualization. If someone wanted to be able to visualize a new type of IR that they had generated or made up, or wanted to display some IR in a different way, all they would need to do is they would need to define some sort of translation to this hierarchical graph structure. Once that's happened, the tool then, it goes through a big drawing pipeline where it decides where to put all the different nodes vertically and horizontally, where it decides where to put all these copy things and how to group things into blocks and put swaps everywhere. You end up with a bundle of shapes, and then you can either directly draw this to an SVG, or you can use our interactive front end. And this interactive front end allows certain features. Again, I'm not sure how well these things are going to show up, but there's certain features you can use to make it easier to explore the graph you're thinking about. So the first one of these is you can hover over any of the wires, and it will highlight the whole edge, including whether it goes into blocks, out of blocks, wherever it goes. The second feature is that you can take blocks and regions and collapse into a single point if you just don't want to focus on that region at the moment. And lastly, we can search for, you can sort of do a find and search for various nodes. I think that's all I want to talk about. You can try it. It should work on WASM. WASM's always been a bit flaky, but yeah, fingers crossed, it might even work on a phone.